It says a man in an ascending hot air balloon throws a set of car keys to his wife, who is on the ground. Okay. The keys are projected at a constant velocity v meters per second at an angle of theta to the horizontal, and from a point v squared sine squared theta g meters vertically above the ground. Also near the edge of a dam located where the balloon took off lies v squared 1 plus root 3 over 4g m horizontally from the point of projection. The dam is v squared over 2g meters wide. The position of the key at given any time is given by that. All right, so let's think what we're saying, right? We've got a man in this balloon. He throws his car keys out, which means the car keys are undergoing projectile motion, which is sort of flying through the air. And he presumably wants to throw them to his wife, who is somewhere on the ground. We don't know exactly where at this point in time. The keys are projected at an angle v and theta, very standard, from a point v squared sine squared theta over g, v meters above the ground, as they've shown here. Near the edge of the dam located where the balloon lies. Okay, so they're basically saying the dam has an edge, which is here, no problem, and that this distance across the dam, the width of the dam is v squared over 2g. Okay, so great. The position is given, so we can just assume that. Well, firstly is calculate the Cartesian equation. Well, that should be pretty clear. I don't think you need help with doing that question, do you? That's pretty standard. It's just that you're going to need to sub 0 h, and h is v squared sine squared theta over g. Part 1 is okay, I assume?
Yeah.
All right, so we'll skip part 1. It's just very simply solve for t sub in. Show that the horizontal range of the keys on the ground is given by that, is given by this. Okay, so again, that's a pretty standard thing. And then find the values of theta for which they will not land. Okay, so 3 might be a little bit more involved than typical, but you can see hopefully that part 1 is a standard question and part 2 is also quite standard. Did you need me to do part 2?
No, I think I'm good for part 2.
All right, so let's now basically, I mean, they're very standard questions. So 1 and 2. So you can see what I mean by a lot of the times, even if you don't get one part, you can get a lot of the marks even before you do that part. So let's draw our own diagram, because that will sort of, we want it a bit bigger and that will sort of help. So now we know that this distance here is v squared 1 plus root 3 over g. And that's all we're given for the moment. Now we know the Cartesian equation, of course, is y equals negative gx squared sec squared theta plus x tan theta plus v squared sine squared theta over g. And that's your typical equation, by x tan theta minus g over 2v squared sec squared theta x squared plus your h. And we also know that the range is given by v squared 1 plus root 3 sine 2 theta over 2g. You are asked to find the values of theta for which the keys will not land in the dam or on the edge of the dam. So in general, you understand that if you throw it horizontally, presumably it will drop to the ground very fast and presumably it's not far enough. So that's kind of, but then as you sort of raise it, you can kind of get further until 45 degrees, presumably you're really far out here, presumably. And then as you get further back, it's going to sort of get too big again. So you really want to find out when the key will land on the edge, and then you get your idea of what angles you want to look at there, right? So we need to sort of find that. Now to find that, the range formula you've got will be very helpful, okay? But we need to know what range we're solving for. Well, one of the edges is here, which is v squared 1 plus root 3 over 4g. So we want to know when r equals v squared 1 plus root 3 over 4g, what angles that are, right? So this is one point that we're interested in. R equals v squared 1 plus root 3 over 4g, which is all over here. But we also want to know here. Now, this is going to be that plus that, because that's the distance. So we're also interested in r equals v squared 1 plus root 3 over 4g plus v squared over 2g. And a little bit of work. Would suggest that you've got v squared 3 plus root 3 over 4g. So we've got these these expressions that we want to solve for. So we'll solve for basically theta, where solve for theta, where r, which was given as v squared 1 plus root 3 sine 2 theta over 2g, is equal to option 1, v squared 1 plus root 3 over 4g. Option 2, v squared 3 plus root 3 over 4g. Okay. Just confirming that those are correct. Good. All right. So if we let r equal this, then clearly you've got v squared 1 plus root 3 sine 2 theta over 2g equals this. And you can see quite clearly the v squareds cancel, the g cancels, the 1 plus root 3 cancels. So really, you're just left with sine of 2 theta over 2 equals a quarter. Alternatively, sine of 2 theta equals a half. Now, if you're going to assume theta is acute, which we should in our instance, then that means for sine 2 theta equals a half, that means your 2 theta is going to be 30 degrees. And theta must equal 15 degrees. So that's sort of one angle that we're going to get there, okay, for acute theta, of course. Of course, we could solve this rigorously, right? I mean, we could have done it as, okay, so 2 theta could have been 150 degrees as well, 180, which then gives me an answer of 75 degrees, which doesn't give me an acute angle of theta. So maybe that'll make things clearer, all right? So we've got 15 and 75. Now, we'll do the same thing here. We've got v squared 3 plus root 3 over 4g, which is going to equal r. So r is going to equal v squared 1 plus root 3 sine 2 theta over 2g must equal this. Now, to save myself a bit of writing, we can factor out root 3 from there, right? And I'm left with 1 plus root 3 once I factor that out. Because I had 3 plus root 3 before. 3 divided by root 3 is root 3. Root 3 divided by root 3 is 1. So that's that. And I'm again going to solve for theta. And as usual, v squared cancels. 1 plus root 3 cancels. G cancels. 2 and 4 kind of cancel. So that's going to give me 2 there. And I'm now left with sine 2 theta equals root 3 over 2. Everything else is gone. And so if I'm now solving for theta being acute, that means I need to solve for 2 theta in first and second quadrant. So that then means 2 theta will equal 60 degrees or 120 degrees, which then means theta equals 30 degrees or 60 degrees. So we've got 4 angles, 15 and 75 for range 1, 30 and 60 for this. So we're saying our answers have given us a theta of 15 degrees and 75 degrees for this one, and your theta equals 30 degrees and 60 degrees for this one. Now, what does that mean for your answer then? Well, remember what we discussed before when we were talking about range in general? So the range of a projectile increases to 45. So when you're going from 0, it's presumably like very short. And so what this 15 degree means is that when you finally throw it high enough at 15 degrees, it lands just on the edge. But when you go higher than 15, 16, 17, 18, 19, you're going to land in the dam. But when you get to the other end, 30, you've now gone far enough that you're landing on the other side. So this theta equals 15, theta equals 30 degrees. So between 15 and 30, you can't do that because you're going to land in the dam. And of course, you're going to keep increasing and go all the way to theta equals 45, which is somewhere out here. But once you get to theta equals 45, your range is going to start dropping again. And then when you hit 60, that's going to be when you do something like this. And I'll use a different color. So 60 is when you do something like this. So it still lands in the same spot, but it's now on the way back. And then so for 60 and higher, 61, 62, you're going to land in the dam again until, of course, your 75 angle, which will do something like this. Which then means our answer to the question, given what we've already worked out, it asks, find the values for theta which they don't land in the dam. Well, theta must be strictly less than 15 degrees. They can't equal because it will land on the edge. Or theta is between 60 and 30. Because if it's between 15 and 30, it's going to land in the dam here. Once it passes 60, it is going to then go here until, of course, 75. So, or theta is greater than 75 degrees. And it should be, all of these should be strictly greater than or less than 60, because remember, we can't land on the edge. So it's strictly less than. And that would be your answer to this question. That's how I do it. Okay. I assume that answers that question.
Yeah.
Any questions at all?
No.
Right.